Hey, geometry students, this is Mr. Butterbaugh. Welcome back to another edition of our notes. Today's notes are titled 6-1, Classifying Triangles. Make sure you get a title on your paper, on your notes there. It really helps to have a title whenever I'm looking for them and you're looking back. I've seen some students not write a title. Please do that. All right, when we're classifying triangles, there's two ways we can do that, either classifying by their angles or classifying the triangles by their sides. If you want to pause the video and get this whole entire chart kind of laid out for us, then we can copy it together as we go through them. You should have already be familiar with how to classify triangles by their angles and sides from middle school, hopefully. And as we do this, we want to realize that most of the time when we classify triangles, we do it both by sides and angles. We're going to go through them separately here just so we can understand what they are. First one is an equiangular triangle. Equiangular. Equa stands for equal, and then angular stands for the angles. So equiangular has all angles congruent. So if we want to draw one of those, all three angles would be congruent. Now you might be saying to yourself, well, that's also an equilateral triangle, and yes, it is. So down here, equilateral has equilaterals, lateral standing for sides, so all the sides are congruent, so I can mark the triangle like there. Now, these two triangles are the exact same. So when you say you have an equilateral triangle, okay, when you say equilateral triangle, it's also equiangular. Or if you would say that we have an equiangular triangle, it's also equilateral. If you say both, it's equiangular and equilateral. It's just kind of saying the same thing twice. So these are in fact the same triangle. When you name the triangle or classify a triangle, when you say equilateral, it's also assumed that's equiangular. But the rest of the triangles we have to classify it by both. So the next way to classify a triangle by angles is an acute angle. That's when all angles are less than 90 degrees. So draw in an acute angle. And that angle clearly has nothing that's 90 degrees, nothing that's bigger than 90 degrees. A right angle will have one 90-degree angle. We've seen that before. And we should mark it with that right angle symbol to help us know. An obtuse angle has one angle greater than 90 degrees. So there's one that's greater than 90 degrees. And clearly that one is past 90 there. In an obtuse triangle, it's only possible to have one angle greater than 90 degrees. Think to yourself, why can you not have two angles greater than 90 degrees? Well, you should also know that all three angles add up to 180. So if two angles are greater than 90 degrees, that's more than 180 by itself. So we can't have a third angle, and the triangle just kind of doesn't make sense then. All right. Classifying the triangles by sides, we've also already talked about the equilateral. An isosceles triangle has at least two sides congruent. So if you draw an isosceles triangle, it's going to have at least two sides congruent. All right, and I put two markings on there just to distinguish it from the one I've already done there. It doesn't mean you have to have both of them there. You can have one slash or two slashes or three slashes as long as you match up the pairs of congruent markings there. And notice we said at least two sides congruent because if you have all three sides congruent, it's still an isosceles triangle, but it's also an equilateral triangle. So an equilateral triangle is an isosceles triangle, always, but an isosceles triangle is not always an equilateral triangle. Make sense? Cool. All right, a scalene triangle has no sides congruent, so it's got three sides. All three sides are just of different lengths. So I can mark them all with different markings on there to help us see that nothing is the same. All right, so it's possible to have, for example, an acute scalene triangle if all the angles are less than 90 and all the sides are different. Or you can have obtuse scalene triangle. You can have an acute isosceles, obtuse isosceles, a right isosceles, and again, I left out the right scalene triangle. You can have any combination of these angles and angles inside. All right, so example one. Copy this down. Pause the video, copy it down. Use the distance formula to find the measures of the sides of triangle DEC. Then classify the triangle by its sides. So we want to bring back the distance formula because some of you guys need some more practice with it. And we can see that we have these 3 points. All right? So on your own chart there that you sketched out, we've got the point D is at 3, 4, 1, 2, 3, 1, 2, 3, 4. Put it out there and label that D. Then I've got a point -5, -2, 1, 2, 3, 4, 5, 1, 2. Put a point there, and that's point E. And then I've got the point C at 2, -3, 1, 2, 1, 2, 3. There is our point C. And then you can draw in the triangle. So there we have our triangle DEC drawn in. All right, and we want to use the distance formula to be able to classify this triangle as it's given. So I'm going to find the length of DE first. All right, and DE, let's remind ourselves, the distance formula is given to us as x2 minus x1 squared plus y2 minus y1 squared. And all that with the square root sign. All right, so for DE, I've got my x1, y1, then x2, y2. So I can plug those in. So we've got negative 5 minus 3 squared plus negative 2 minus 4 squared. Okay, simplify that. Some of you guys like to plug all that in the calculator, which is kind of okay. If you plug everything in without the square root sign, then put that square root sign back on there and put it in there. I like to go ahead and do it by hand just so I can make sure I'm doing it correctly and I understand what it means. Negative 5 minus 3 is negative 8, and negative 8 squared is 64. Negative times a negative is a positive, so I should get that. Negative 2 minus 4 is negative 6. Negative 6 squared is 36. So I end up getting the square root of 100. And if you plug all this in the calculator at once, you should get 100, and that would go into there. And I know the square root of 100 is 10. So DE here I have a length of 10. Next one, I find the length of EC. So square root from E to C, just take your coordinates. This is now my 1, 1, 2, 2, stuff like that. All right, guys, can pause the video and work this out yourself, then replay it and see to make sure you did it correct. I'm just going to work this through. I'm not going to talk about it while I do it. You should be able to feel comfortable using the distance formula by now. All right, so there we have it. I've got my lengths of all three sides, and notice I just left my sides as square root of 50. I could have simplified the radical out, but the exact answer is just square root of 50. And I've got two sides here that are going to be the same. So I notice this is an isosceles triangle. That's my answer there. Last example here says the angles of a triangle are in the ratio of 3 to 2 to 1. Find the measure of each angle and classify the triangle. All right, this is a little bit different problem, and I'm doing this example because it's a little bit different direction, and I want to make sure we can understand it. We'll have a couple more to do in class. I know that all three angles add to 180, so three angles equal 180 degrees. So if the ratio is 3 to 2 to 1, that would mean that there's a multiplier here for each angle that's going to add them to add them to 180. I don't know what that multiplier is, so I'm just going to call it x. So 3x is the first one, and I can add to it 2x plus 1x. All three angles add up to 180 degrees then. So I need to find out what is this multiplier here to know the angles of the actual triangle. So 3x plus 2x plus 1x is going to equal 6x. So 6x equals 180. Divide by 6. So x equals 30. So I know if I had a triangle then, this is x, 2x, and 3x. All right, the x would be 30. 2 times 30 is 60, and then 3 times 30 is 90. So by the angles of this triangle, I've got one 90-degree angle. Now, I didn't draw it correctly. I'm just sketching out a triangle easily. So I see I have one 90-degree angle. That means it's going to be a right triangle. And then all three angles are different. None of them have the same measure, so the sides across from these angles are going to be all three different sides as well. So all three different sides is a scalene triangle. So this is a right scalene triangle, and I hope you guys have a great day.